Hello, everyone. Welcome back to Python Challenge for All. Okay, let's see where we were last time.
Yeah, right. We were making number guessing game, whatever you call it. Okay, so let's check. And the homework was still the range of numbers in the beginning. Okay, so let's go back to our Python code E3. Open the E3 notebook, connect, and let's see the last part here. Okay, so we need to import random. Max num is, let's see, back to 10. Okay, so from 1 to 10, this was it. Let's check whether it works right. Okay, guess first round. Okay, 7. Okay, lower, 4. Okay, even lower, 2. Correct in round 3. Okay, good. So the assignment was to show maybe the range in the beginning. So, well, we can change it this time. Let's see, between, well, we can change it. Maybe we don't need this. So range is 1 and maximum. Now, this is enough, right? Okay, let's see it. Range is 1 to 10. Okay, let's change it to 100 or 50. And let's check that. Okay, guess range is 1 to 50. So 30. Okay, lower, 10. Lower, okay, 4. Higher, 7. Higher, 8. Correct. That's right. Okay. Of course, if you want, yeah, okay, this is what we want. Okay, fine. Okay, maybe sometime later, we might come back to this problem and further changing it. Okay, let's go on to today's lesson. Today's lesson 25. Okay, prime numbers. So, what are prime numbers? Do you know what are prime numbers? What prime numbers are? Yeah, maybe you know it. 2, 3, 5, 2, 3, 5 that are divisible only by its number. Okay, so which is not composite numbers like 6 or 8 or 9, right? So let's check finding prime using its number of factors. So we learned how to count the number of factors. So let's try that first. So maybe we can make a new box. Text here, prime number. Okay, here is kind of a new title text. So we learned that to define div functions, right? So divs for n, like return, right? So I for I in range range 1 to n plus 1 if I is divisible by, no, n is divisible by I, meaning that if the remainder, if divided by I is 0, it's a divs factors. Maybe we can change it factors. Okay, so let's see if this works. works fine. So factors of 12 is 1, 2, 3, 5, 4, 6, 12. Okay, so let's check again for k in range 1 to say 20. Print factors. Let's see k first, and then factors k. So let's print and check. 1, 1, 2, 1, 2, 3, 1, 3, 4, 1, 2, 4, 5, 1. So looking at this, what do you observe about the relationship of the prime numbers and the number of factors? Right. You see that for prime numbers only, the number of factors is 2, like 2, 3, 5, 7, 11, 13, 17, 19. And others are longer than 2, bigger than 2, right? So this way we can find primes. That's the basic idea. Find prime numbers below 20. So it's like this. For k in range 1 to 21, print if length of factors k equals 2, print k. Just to make sure, let's print. Wow, we don't need to write it. So this is the simplest way to find prime numbers. Sorry, something is wrong. We don't need parentheses here. Okay. So 2, 3, 5, 7, 11, 13, 17, 19. That's what we want, right? Or otherwise, as we learned, we can make a list of prime list equals empty. And if the condition is met, prim L, append K. And this will make a list of primes under 20. Good. So you know what the idea is. For composite numbers, the list is longer than 2, like 3, 4, 6, something like that. Okay, in one line. So we learned that if we write something in this kind of loop list, we can write it in one line, right? So L equals, we don't need this time. So maybe for k in range to 21, if, right, this one, then of factors 1 to 20, no, factors k equals 2, block parentheses. Okay, so this will make the same list. Sorry, I forgot to write k here. K for k, k for k. Okay, we want k for here, so k for k in range, right? Or even, maybe we can copy and paste, copy this part in here and changing k, n to k. This is really one-line solution. Okay, right, good. Or we can try up to 50. Let's see the next one. How many primes are there below 50? So if we change it to 51, we can enumerate all the prime numbers up to 51. 50. 2, 3, 5, 7, 19, 23, You can check yourself if this is correct. And there is no missing primes. Okay, so how many primes are there below 50? So if we can answer this by putting len followed by it. There are, I don't know how I can misspell it. Okay, there are 15 prime numbers below 50. This is the answer, and this is a single line, beautiful, simple question, solution. Good. Did you understand that? Please check yourself about how you got this and how you can arrange to do the same work task. Okay, that's all for today. Homework. How many primes are there below 100, 1,000, or 10,000? Or can you do it even further? Yeah, it's an interesting topic. Please try it. And hope you liked it. That's for today. That's all for today. So see you next time. Bye bye.